Today we're talking about one of the strangest ideas in tech right now, taking the giant warehouses full of computers that run AI, data centers, and launching them into space. Not the data, the actual machines, in orbit. And serious companies are trying to do it. Your first reaction is probably, why on earth would anyone do that? It sounds absurd and expensive and hard. But there's a real argument behind it, and an even more interesting reason it might not work. By the end, you'll understand both the dream and the catch. This matters because AI is eating power, land, and water at a staggering pace. Every new model needs more computers, and those computers need somewhere to live, something to power them, and something to keep them cool. We are running into physical limits here on the ground. So a few companies are asking a wild question. What if the ground isn't the best place for this anymore? What if the cleanest power and the emptiest real estate are actually up there? It's a strange idea, but the pressure making people ask it is very real. Start with the case for it, because it's stronger than it sounds. Reason 1 is power. In the right orbit, the sun never sets. No night, no clouds, no atmosphere dimming it. A solar panel up there soaks up sunlight almost around the clock, far more than one on the ground. On Earth, solar stops at night and sputters in bad weather, so you need batteries or backup. In the right orbit, you get near constant, free, clean sunlight. For something as power-hungry as an AI data center, that endless energy is the whole temptation. Reason 2, space is empty. No land to buy, no neighbors to anger, no local water supply to drain for cooling. On Earth, data centers fight communities over land, power, and water. In orbit, there's nothing to fight over, just a whole lot of nothing. And reason 3, quieter but real, security and location. A data center in orbit is physically hard to reach or tamper with, and it sits right next to the swarm of satellites already watching Earth, handy if you want to process all that data without beaming it down first. Now here's where most people's intuition goes badly wrong. You'd think space is the perfect fridge, it's freezing out there, right? So cooling a data center should be easy. It is, in fact, the single hardest part of the whole idea. And the reason is beautiful physics. On Earth, your computer dumps heat into the air and water around it. The heat has something to touch and flow into. Space is a vacuum. There's nothing out there to touch. And you cannot pour heat into nothing. So the cold of space is almost useless to you. There's exactly one way to shed heat in a vacuum, radiate it away as infrared light, slowly. That's how everything in space cools, by glowing. The radiating heat is far weaker than blowing air or running water over it. So getting rid of heat becomes the bottleneck of the entire machine. Which means an orbital data center needs enormous radiator panels, vast wings whose only job is to glow away waste heat. The more computing you do, the more heat you make, and the bigger those radiators must get. For a serious data center, they could dwarf the computers themselves. So if the cooling is that hard, why is anyone even trying now? One word, and it's the thread running through this whole series: launch. Thanks to reusable rockets, the cost of hauling mass to orbit is collapsing. Suddenly, lofting heavy hardware upstairs is no longer unthinkable. Remember the falling price per kilogram from last episode? This is one of the wild new things that cheap number unlocks. When launch was astronomical, orbital data centers were pure fantasy. As launch gets cheap, the fantasy edges toward a spreadsheet someone can actually run. So how would one actually work? Picture a spacecraft built from 3 main parts. First, the computers themselves, racks of specialized AI chips, the same kind filling data centers on the ground, just hardened for space. Second, huge solar arrays stretching out like wings to drink in that constant sunlight and power the chips. And third, those big radiator panels we just met, spreading out on the other side to glow the waste heat away. Compute in the middle, power on one side, cooling on the other. Then there's the question of talking to it. The results have to get back to Earth somehow, beamed down as radio or, increasingly, as focused laser light, which can carry enormous amounts of data. So the data center thinks up in orbit and whispers its answers back down to us. Now the catches, because this is where the dream meets reality. The first is latency, the travel time for a signal. Even at the speed of light, going up to orbit and back adds a delay. For anything that needs an instant answer, that round trip is a real problem. So an orbital data center is terrible for things that must feel instant. A chatbot replying to you, a game, a video call. But it could be fine for work that runs for hours or days and doesn't care about a little delay. That difference decides what space compute is even good for. The best fit is training, the long, brutal number crunching that teaches an AI model in the first place. That can churn away for weeks and doesn't need to be milliseconds from a user. Answering your questions in real time, though, that work almost certainly stays on the ground. Latency isn't the only wall. Space is a hostile place for electronics. Radiation up there flips bits and slowly fries chips, so everything needs special hardening, which makes it heavier, pricier, and often slower than the cutting-edge hardware you'd use on Earth. And when something breaks, and in a data center, something is always breaking, there's no technician to walk over and swap the part. A dead server on the ground is a 5-minute fix. A dead server in orbit might be dead forever, or need a wildly expensive robotic repair mission. There's also the traffic problem. We're already crowding orbit with satellites, and big data center platforms with huge wings are large, collision-prone targets. Add enough of them, plus the debris risk we talked about, and you start to worry about the neighborhood getting dangerous. Then there's the law, which mostly doesn't exist yet. Who licenses an orbital data center? Who gets which slice of radio spectrum to talk to it? What are the export rules on flying advanced AI chips into space? Whose fault is it if one crashes into someone else's satellite? These aren't small questions. Advanced chips are tightly controlled on the ground for national security reasons. Launching them changes the game. And space law is a patchwork of old treaties never written with private data centers in mind. The rules will have to race to catch up with the rockets. So how real is all this, honestly? Right now, early. A handful of startups and demos are testing small pieces, a few chips in orbit, a proof of concept. Nobody has a giant humming AI data center circling the planet. This is the very first wobbly step, not a finished thing. It might turn out that the heat problem, the repair problem, and the cost simply never pencil out, and this stays a niche stunt. Or falling launch costs and clever engineering crack it open. Both are genuinely possible. Anyone who tells you they're certain either way is selling something. But it's worth watching, because it's a canary. If AI's hunger for power and cooling gets desperate enough that launching computers into space starts to look reasonable, that tells you something huge about the crunch we're hitting down here on the ground. So what should you actually keep an eye on? 3 things. First, launch cost. The whole idea lives or dies on how cheap it gets to loft heavy hardware. If the price keeps falling, the math keeps improving. Watch that number again. Second, cooling breakthroughs. Whoever figures out how to radiate huge amounts of heat with lighter, smaller panels changes everything, because heat is the true bottleneck. And third, watch whether anyone flies real AI training up there, not a demo, but actual work. That's the moment it gets serious. Zoom out, and orbital data centers are really about one question: where does the physical stuff of the digital world belong? For a century, we assumed the answer was somewhere on the ground. AI's appetite is now big enough that, for the first time, we're seriously asking if the answer might be up. So here's the one thing to remember. Putting data centers in space isn't crazy because of rockets, it's hard because of heat. The vacuum that gives you endless sunshine also traps your waste heat with nowhere to go. Solve that, and the strangest idea in tech gets a lot less strange. If this bent your brain a little, subscribe. We've got a whole series unpacking the future you're about to live in. And speaking of that crunch on the ground, next time, we tackle the big scary headline: how much water do data centers actually use, why we need them anyway, and what happens if China wins this race. See you there.